Hello, grade 10. So this week, as we finished till now, logarithmic function and exponential function, this week we solved some of the official exams related to our lessons. So I'm going to solve an exercise again with you. So if you have any problems with the questions, you can understand it clearly. So first of all, this is the 2024 first official exam. We are given a function which is ln x over x plus 1, and its representative curve is c. First of all, you have to determine the limit when x tends to 0. Of course, it's 0 plus because the domain is from 0 to plus infinity. And after that, they ask you to deduce an asymptote. This would give you a hint that the limit when x tends to 0, it's either plus infinity or minus infinity because they asked us to deduce an asymptote, okay? So these are important hints in the official exams, so you would check that your answer is correct. Anyway, let us do the limit when x tends to 0. Len 0, it's minus infinity. Minus infinity over 0 plus, instead of x, you're going to replace 0 plus 1. Minus infinity over 0 is minus infinity, and minus infinity plus 1 is minus infinity. So as I told you before, we know that our answer is either minus infinity or plus infinity. So we got the answer minus infinity. Then now we know that x equals to 0, which is the y-axis, is a vertical asymptote for the curve C. Now we need to determine the limit when x tends to plus infinity, and we need to show that we have an oblique asymptote, which is D. They gave us the given, let D be the line with the equation y equal x plus 1 is an asymptote to C, and then the relative position. So why these questions are related to the same part? Because usually when we do x tends to plus infinity and we get an infinity, we can tell that we have an oblique asymptote. So these parts are related, so you would know that the limit when x tends to plus infinity is definitely, it's either plus infinity or minus infinity because we have an oblique asymptote. It's not a number. We don't have a horizontal asymptote, okay? So this is another hint from the exam to tell you that the answer of the limit, it's either plus infinity or minus infinity. So let us do the limit when x tends to plus infinity. We have ln x over x plus 1. Ln plus infinity is plus infinity. Plus infinity over plus infinity, this is IF. Okay? So what do I do in this case? We do Hopital rule. We do HR rule. What does the HR says? We have to do the derivative of the numerator over the derivative of the denominator. So we will have 1 over x. What's the derivative of ln x? It's 1 over x over 1. Okay? So the final uh, part is 1 over x. So now we have 1 over x plus 1 that we need to do their limit all over again. So we need to do the limit when x tends to plus infinity. Now number over infinity, if you replace 1 over infinity plus infinity plus 1. Okay? Number over infinity is 0. 0 plus infinity plus 1. Then the limit when x tends to plus infinity is plus infinity. We already know that the answer is infinity, but we can't tell if it's plus or minus. Now we identify that it's a plus infinity. Okay, so we are done from the limit. Now we need to tell that D is an asymptote to C. How can we prove that a line is an oblique asymptote? This is two steps verification. The first step, you have to do f of x minus y. F of x means the curve, y means the asymptote. After doing y, f of x minus y, we need to do the limit when x tends to plus infinity. It should be 0. If you do f of x minus y, means you have to do f of x here minus the oblique asymptote. So ln x over x plus 1, this is the function, minus x minus 1. So plus x minus x plus 1 minus 1. So we already have ln x over x. This we need to do the limit when x tends to plus infinity. But according to the part above, we had IF. It's an indeterminate form. So, but we already did the Hopital for it. So we take the answer as it is. Don't do it again. Don't do Hopital again. You just to put it like this. And now you put it when x tends to plus infinity here, not 0. Okay, so pay attention. This is plus infinity. Number over infinity is 0. Because we had an answer of 0, that means it's verified that y equal x plus 1 is an oblique asymptote. Okay, now we need to tell the relative position of the curve and D. How we do this? After finding f of x minus y, we need to discuss the answer, if it's positive or negative, if it has a root or not, okay? So we take the answer of f of x minus y, which is ln of x over x, and we put it equal to 0. Of course, we're going to take the numerator, ln x equals to 0 when x equals to 1. As I told you, you do a small table like this. You put the 1, its opposite same, so minus plus. So between 0 and 1, the curve, because it's negative, it's below the oblique asymptote, okay? And between 1 and plus infinity, the curve is above uh, the oblique asymptote, and at 1 exactly, they meet. Okay, so for x greater than 1, the curve is above. For x belongs to 0 to 1, the curve is below. I'm going now to erase everything to continue the question. After calculating or after finding the oblique asymptote, they are asking you to complete the following table. As if they are telling you that f prime of x is positive for every x. So no need here to calculate the derivative. See, they already gave you the table. Just complete it. So you don't do the derivative, okay? So it's plus, so you just do an increasing arrow. At 0, we got minus infinity as limit. Okay, and at plus infinity, we got plus infinity. So that's the table. So no need to do the derivative at all. Okay, and the related question as usual. You need to show that the equation f of x equals to 0 has a unique solution, and then verify that this solution is between 0.4 and 0.5. These are two related parts. That's why they every time come together. How do we answer? Before I answer, as I always tell you, whenever they tell you that f of x equals to 0 has a unique solution, that will give you a hint that the table of variation is increasing for every x or decreasing for every x from a positive to negative or from negative to a positive. That would give you a hint that your table is correct, okay? So pay attention to this. Why f of x equals to 0 has a unique solution? Because f of x is continuous and strictly increasing from minus infinity, which is a negative value, to plus infinity, which is a positive value. Then f of x definitely will admit a unique solution. Okay, so I have to answer f of x is continuous and strictly increasing over 0 to plus infinity, from minus infinity, which is a negative value, to plus infinity, to which is a positive value. Now, how can I tell that the root alpha is between 0.4 and 0.5? You do f of 0.4, okay? F of 0.4 and f of 0.5. What I'm sure about that f of 0.4 will give me a negative value. Of course, you put it on the calculator, okay? And 0.5 here, sorry, it's a positive value. How did I know? Because it's actually increasing. So the value 0.4 will give me a negative value, but the 0.5 will give me a positive value because alpha is in between them, okay? So since the function is increasing, 0.4 will give me a negative value and 0.5 will give me a positive value. Now the only part that's left is to draw the curve. After having the table of variation and the relative position, we need to draw the curve. As you can see, the first thing you do is to put all the asymptotes. What do we have as asymptotes? We have the y-axis as asymptote, okay? and we have the oblique asymptote here. This is the oblique asymptote we draw it. You need to mark on the curve. I don't know if it's clear for you, but you have to put the alpha on the curve. And here you have the point of intersection of the curve with the oblique asymptote. It's strictly increasing from minus infinity to plus infinity, but it passes um, through alpha and this point of intersection. We already said that between 0 and 1, the curve is below the oblique, and after 1, the curve is above 1. So sometimes you might do it increasing in this way, but below the oblique. But because you already discussed this and you said it's above, so after having 1 as a point of intersection, you put it above the oblique asymptote. So every step in this question is important for drawing at the end of the question. I wish that it's clear for you what we have done for today. It's an official exam exercise. They are all related. They all they have the same parts. I advise you to complete the session. And if you have any question, of course, you can ask.